So let's go ahead and flip the page over and let's take a look at a couple of these problems. So these are more kind of unit rates in context. It says unit rates, use unit rates to decide which is the best deal. Be sure to show your work and your thinking. So as we go through this, you're going to be presented with two scenarios and you've got to figure out which one is the best deal. Now when we say best deal, it means which one's going to be the best in that particular situation. So Hannah sells M&Ms out of her giant backpack for 5 cents. And a machine at the store sells you 18 for 25 cents. So should we do M&Ms per penny, per cent, or should we do cents per M&M? Probably a good idea to do cents per M&M. So we're going to do 5 cents, and I'm going to do it like this, per 4 M&Ms. And on this one, we're going to do, let's see, this was 25 cents. Again, the cent symbol goes in back. The dollar symbol, if we used one, it would go in front. Divide by 18 M&Ms. So on this one, if we carry out the division, and I'm going to do this one just really quickly, I won't do all these on the calculator, but so if we do 5 divided by 4, 1.25. So this is 1.25 cents, so about 1.25 cents per M&M. All right. So we've got that answer right there. Let's do this one this way so we're comparing those unit rates right next to each other. I'm going to put periods there so it doesn't look like millimeter. So on this one right here, let's do 25 cents divided by 18. And we end up with, let's see, so this is 1.3888. So if we were to round to the nearest hundredth of a penny, this would be 39. So we're going to call this 1.39, and this would be cents per M&M. So if you were buying M&Ms, where would you want to buy them? Who's giving you the best deal? The machine at the store or Hannah selling out of her big backpack there? That's going to be the best deal right there. So I'm just going to put a check mark by it. So a lot of these problems are set up the same way. On this one, it's going to be 10 cards for 35 cents. 12 for 40 cents at the store. So again, I'm going to put 35 cents at the top, and on this one I'm going to do the dollar sign here and divide by 10. So over here this is 40 cents, so I'm going to do the dollar sign, 40, and we're going to divide by 12. Most of the time the dollar or the money amount, whether it's dollars or cents, ends up going on the top, and then whatever the other quantity goes on the bottom. Usually, but not always. Most of the time the money goes on the top. So if we do this one right here, this is, so if we go ahead and divide, we'd move the decimal over one place. So this would be 0.035 dollars. So that's no dollars, 3 cents and a little bit more. So it's about 3.5 cents. And if you want to do it like this one up here, that's totally okay. Thought I'd just do one using dollars. And that would be per one card. So per one baseball card. Okay, and this one over here, let's see what we've got here. So this is going to be 0.40 divided by 12. So we end up with, let's see, 0.33. So let's see, we'd have dollar sign and 0.033. So if we go enough decimal places, then we can kind of see what we're looking for. So this is about 3.5 cents, 3 cents and a little bit more. This is 3 cents and a little bit more, but not quite as much as that one right there. So we actually get a better deal at the store on that particular one. Alright, this is kind of an interesting one. At summer camp they have Frosted Flakes and Raisin Bran for breakfast. Frosted Flakes has 11 grams of sugar in each 8.5 ounce serving. Raisin Bran has 13 grams of sugar in each 9.2 ounce serving. You're diabetic and you need to eat as little sugar as possible. Which one should you choose? Now, most everybody knows somebody with diabetes, and it's a tough disease to deal with. And I think these are actual numbers. If not, I think they're pretty close. Sometimes it can be pretty surprising which type of cereal has more or less sugar. So on this one, we've got 11 grams in an 8.5 ounce serving. So would we want to do ounces of cereal per gram of sugar, or should we do grams of sugar per ounce of cereal? It's probably going to be better to figure out how much sugar is in each ounce than the other way around. So we're going to do 11 grams of sugar in each 8.5 ounce serving. That means on the other one we would put 13 grams on the top, and we would put 9.2 ounces, and remember the abbreviation for ounces is OZ. So let's go ahead and throw this in the calculator and see what we get here. So this would be 11 divided by 8.5. Let's carry out several decimal places because you never really know how this is going to work out. So let's do 1.294. Alright, so 1.294. Make sure I got that right. Yep, so we're in good shape there. And this would be grams of sugar per ounce. 1 ounce if we want to do that. Okay. Now, it's not absolutely necessary to put the sugar there, but let's do the same thing over on this one. So let's do, this is going to be 13 divided by 9.2, 13 divided by 9.2, and we end up with 1.413. So it turns out, gosh, you could tell really easily that that one was going to have less sugar, but let's do 1.413. 1.413, that's grams per 1 ounce of cereal. So there are two options, and if we were a diabetic and we wanted to keep our sugar intake down, this is going to be the better choice. Frosted Flakes, oddly enough. Okay, and you might want to, if you're a diabetic, you definitely ought to check out whether or not that's really the case. But anyway, hardware store sells sparklers for the 4th of July. They charge 19 cents a piece. So 19 cents a piece, that means 19 cents for each one. So this one's going to be 19 cents for one sparkler. And this one right here, they charge 89 cents for 5. So this one's going to be 89 cents. Whoops, we'll do it this way. 89 cents for 5. So if we go ahead and do the division here, you may know exactly what the answer is just kind of by looking at this. But if we do 89 divided by 5, this is going to be 17.8 cents. 17.8 cents for one sparkler. So we've got our 2 unit rates that we're comparing. And if you were buying these, this would be the better rate. So let's finish this up with this last problem. So you get 2 offers to help a neighbor clean their yards. Neighbor A will give you $50 for 6.5 hours of work, and neighbor B will give you $35 for 4.5 hours work. And which is the better deal here? So again, the money usually goes on the top, so we're going to do $50 on the top here. And since it's a story problem, let's do 6.5 as 6.5. So this is going to be 6.5, and again, this is hours. And then the other one is $35, so $35 on the top and 4.5 hours. So we're going to do 4.5. So let's figure out what each one of these is. So let's see, this is going to be 50 divided by 6.5. And let's take a look at how we'd round that. Let's round to the nearest penny. So this is $7.69 and a little bit more, but that's not enough to bump that up to a 10, which would make that 70 cents. So we're going to do 69.2 cents, so that's going to be $7.69 per hour. Okay, so that's the first offer. And then your other neighbor is going to do, let's see here, $35 for 4.5 hours. So we're going to do 35 divided by 4.5. And that's 7.777. Now this is 77 cents and a little bit more. That is enough to round that up to an 8. So this is going to be $7.78. So $7.78 per hour. So there are the 2 offers. If you had to choose, this one is a slightly better deal, but you're probably just going to be a good neighbor and help them both out.